All right, for this problem, let's take a look at problem 4.4. A website requires a password that has either 3 or 4 or 5 characters. Each character can be either an uppercase letter, a lowercase letter, or a digit. So there's 26 possibilities for uppercase digits, 26 possibilities for lowercase letters, so uppercase letters, 26 possibilities for lowercase letters, and 10 possibilities for digits. So how many passwords are possible? So each character, there's 62 possibilities. So using the sum rule, there's 26 possibilities that are uppercase letters, 26 that are lowercase letters, and 10 digits. So the number of passwords that are possible, each character, there are 62 possibilities. And there are 3 characters. So the second character, there's also 62 possibilities. The third character, there's also 62 possibilities. And so if the password is 3 letters long, then the answer would be 62 to the third. Now there's 2 other possibilities. What if it's 4 characters long? Well, if it's 4 characters long, by the same argument, it'd be 62 to the fourth. And if it's 5 characters long, it'd be 62 to the fifth. So this right here would be the answer if it's 3 characters long. This would be the answer if it's 4 characters long. This is the answer if it's 5 characters long. Now, these are the 3 possibilities, so once again, by the sum rule, I can add these up, and that would be the total number of possible passwords. This would be the number of 3-character passwords, that's the number of 4-character passwords, that's the number of 5-character passwords, and so if I add these up, that would be the total number of passwords where the length could be either 3 or 4 or 5. Okay, so the answer to this, if you just plug into the calculator, and assuming I did the arithmetic right, is 931,147,496. So that would be the answer to part 1 of this. All right, now before I move on to part 2, I'll mention again, this is use of the sum rule twice and the product rule once, basically. We figured out that each character, there's 62 possibilities, by adding up 26, 26, and 10. We multiplied 62 by itself in order to figure out the number of possible passwords, and then I added these 3 things up because there are 3 possible lengths of the passwords. So our answer is 931,147,496. Part 2. Suppose that the website makes the extra restriction that at least one of the characters must be a digit. How many passwords are now possible? So let's do the 3-character case first. 3 characters, there are 62 to the third possible passwords that we just discovered for part 1. Now let's figure out 3 characters, but no digits. Suppose that the password is 3 characters long, but none of them are digits. If none of them are digits, then that means that each one is either an uppercase letter or a lowercase letter. So there's 52 possible choices for each character. So there's 52 possibilities for the first character, 52 possibilities for the second character, 52 possibilities for the third character, which means 52 to the third possible passwords that have no digits. And so therefore, if I subtract 3 characters, and the complement of having no digits would be at least 1 digit. And so the answer there would be 62 to the third minus 52 to the third. And so that would be the number of passwords that have at least 1 digit. So you notice we figured this out indirectly. Counting the number of passwords that have at least 1 digit directly by just kind of listing out the possibilities is tedious. It can be done. It's a whole lot easier to do it this indirect approach, where I figure out the complement, the numbers that have the number of passwords that have no digits, and then subtract to figure out how many have at least 1 digit. So by the same argument, my answer is going to be, well, if it's 3 characters long, it's going to be 62 to the third minus 52 to the third. If it's 4 characters long, by the same reasoning, it'll be 62 to the fourth minus 52 to the fourth. And if it's 5 characters long, it'd be 62 to the 5th minus 52 to the 5th. And I add these things in brackets because these are the 3 ways that I could construct a password. Either this way with 3 characters, this way with 4 characters, or this way with 5 characters. Okay, so we plug into the calculator, and assuming I did the arithmetic correct, I get 543,491,240. And so the total number of passwords is about 931 million, and slightly more than half of them have at least 1 digit.